Imagine that we could really have a time machine that would show us what happened in the early universe, a machine that would become more powerful and give us progressively clearer pictures even as it aged. Imagine that the machine could detect worlds beyond our solar system, help map invisible dark matter, and characterize the expansion of the universe. It may come as a surprise, but this time machine does exist and is silently floating above us. Familiar enough to many to be taken for granted, the NASA ESA Hubble Space Telescope celebrates 2 astonishing decades in orbit on the 24th of April.
This is the Hubblecast, news and images from the NASA ESA Hubble Space Telescope. Travelling through time and space with our host, Dr. J, aka Dr. Joe Liska.
Wow, this thing travels over 28,000 kilometers per hour, 930,000 observations, 570,000 images of 30,000 celestial objects. 20 years, 2 decades and 110,000 trips around our planet.
Dr. J, 30 seconds to showtime.
Okay. After 2 decades of service to the scientific community and the public worldwide, a real honor to be able to celebrate my dear friend Hubble. Tonight, we pay tribute to your venerable achievements and we look forward to the work that lies ahead of you. We will look at some of your most outstanding accomplishments and your most loved images from the past 20 years. One of your most recent achievements takes us back to the early days of the universe.
Scientists and space mass of its black hole are closely interconnected.
Hubble could also be honored with a Congeniality Award for getting to know our neighbors in the solar system. Hubble has imaged most of the planets and has the advantage of being able to carry out long-term studies from its vantage point 600 kilometers above the Earth. Have you ever been lucky enough to see the enchanting northern or southern lights? Well, Hubble has captured the alluring aurorae that light up the poles of the gas giants Jupiter and Saturn. And it has caught glimpses of comet impacts on Jupiter. Aside from the planets, Hubble has also studied asteroids, like the 500-kilometer sized Vesta. The resulting map of its surface shows a strange world with a gigantic impact crater and possibly even ancient lava flows.
But what is happening beyond our immediate cosmic neighborhood? This is a topic that fascinates many of us, and Hubble has not only helped to detect worlds outside the confines of the solar system, but it can also help to characterize them.
In November 2001, Hubble made the first direct detection of the atmosphere of a planet orbiting another star. In this case, it was the Sun-like star HD 209458, located about 150 light-years away in the constellation of Pegasus. Knowing the makeup of a planet's atmosphere allows scientists to determine whether life as we know it could conceivably exist on the alien world. In 2008, Hubble made the first visible light image of an extrasolar planet. It's in orbit around the bright southern star Fomalhaut, which is about 25 light-years away in the constellation of Pisces Australis. The star is surrounded by an immense debris disk, measuring over 35 billion kilometers across. The planet is orbiting about 3 billion kilometers inside the disk's sharp inner edge, which is about 10 times the distance between Saturn and the Sun.
By measuring bright stars that vary predictably, known as Cepheids, Hubble has been able to use these stars as distance markers, laying a firm foundation for subsequent measurements that led to the discovery of the accelerating universe and a more precise determination of its age.
Astronomers have used Hubble to observe Cepheids and to pin down their distances much more accurately. These results were used as a stepping stone to measure the distances to supernovae, which in turn told us about the scale of the universe. As a result, today we know the age of the universe with much more precision than before Hubble. It is about 13.7 billion years. In the 1920s, Hubble's namesake, the astronomer Edwin Hubble, discovered that the universe was expanding. The observatory that bears his name helped to determine the rate of this expansion and to show that in fact this expansion was accelerating. This was the smoking gun that pointed to the existence of the elusive dark energy.
When we look up at the night sky, it is easy to believe that space is just a giant void with some twinkling stars and a few recognizable planets. However, we must remember that there are structures and matter that we cannot see. Hubble is helping to define in 3 dimensions the distribution of ghostly and invisible dark matter in the universe.
Studies completed in 2007 and earlier this year gave astronomers a clearer idea of the structures that lie between galaxies. Now, these structures do not contain any stars, and they're made up mostly of dark matter, which makes them somewhat difficult to identify. By analyzing the Cosmos survey, which is the largest survey ever undertaken with Hubble, international teams of astronomers were able to obtain one of the most important results in cosmology, a 3-dimensional map which gave us a first and unique look at the web-like large-scale distribution of dark matter in the universe. This landmark result accurately confirmed our theory of structure formation.
Hubble has allowed for many comprehensive studies of the life and death of stars, the way stars develop, live their lives, and eventually die. Closely following the timeline of stars, we get a better idea of what is happening in our own galaxy and others.
Sensitive infrared instruments on board Hubble allow us to peer through clouds and columns of interstellar dust to witness the birth of stars. Many Hubble images feature blue, hot stars at the early stages of their lives. At the other end of the stellar lifetime, Hubble lets us see remote supernovae.
Now that you've caught up with Hubble, make sure to get the latest from the ground too. The ESOcast highlights the best of the European Southern Observatory and its powerful telescopes that observe from high in the Chilean Andes, at the Southern Hemisphere's best-known sites for astronomical observations.